Welcome back to Teacher Gimble's channel. Today we're going to be going over Illustrative Math, Geometry, Unit 1, Lesson 3 Practice. If you like this video, please make sure to like and subscribe so you can see more like it. Let's get started. Problem 1. This diagram is a straight edge and compass construction. We just talked about this construction in the last video, so if you need a second to go back and review how you create this type of construction of the overlapping circles, then make sure to go back and check that out. A is the center of one circle and B is the center of the other. Select all the true statements. So we have line CD is perpendicular to segment AB. So we have line CD, which is right here, is perpendicular to AB. Now, if you recall, when you create these two overlapping circles that share the same radius and connect the intersections of the circles, this intersection does create a perpendicular bisector. Perpendicular means that they cross at 90-degree angles, and bisector means that the segment on the left, AM, is the same length as the segment on the right, MB. So, when we ask, is line CD perpendicular to AB? Yes, it is. We write that in geometry language as CD perpendicular to AB. Is point M the midpoint of segment AB? Well, as we just talked about, this is a perpendicular bisector, and bisector means to split in half. We just split segment AB in half, which means this half is going to be equal to that half, which means M is the middle of the segment. So yes. Is the length of AB equal to the length of CD? AB here equal to CD. Well, AB is a radius of both circle A and circle B. CD is not a radius, so we cannot conclude that they are congruent or the same. Is segment AM perpendicular to segment BM? Well, we got segment AM here and BM there. Neither are part of our perpendicular bisector, the piece that actually bisects it. So no, we can't say that they are perpendicular. Now, I'm going to erase my drawing so we can do this last question and visualize it. In geometry, drawing is your best friend. Is CB plus BD greater than CD? So CB is this guy, and BD is this guy. Is he greater than CD? Well, to get from C to D, we know the fastest way is a straight line, and this is a straight line from C to D. This pink, which is CB plus BD, represents a different way to get from C to D, which is not a straight line, which means by default, it does have to be bigger or longer than the direct path from C to D. So yeah, this one is true. All right, we're going to go on to the next question, but pause the video if you need to go over this or reflect upon it yourself before moving forward. Problem 2. In this diagram, line segment CD is a perpendicular bisector of line segment AB. So CD is a perpendicular bisector of AB. They already drew my right angle mark, but because I know AB is bisected, which means M has to be the middle point, I'm going to mark 2 lines here, which tells me AM is congruent to 2 lines here, BM. I always like to mark everything I know in my diagram, even before jumping into the question. So we know we have CD is a perpendicular bisector of AB. Assume the conjecture, and that's just a math hypothesis. It's a fancy word for a math hypothesis, that the set of points equidistant from A to B is the perpendicular bisector of AB true. Is point E closer to point A, or is point E closer to point A, closer to point B, or the same distance between the points? Explain how you know. So I got to read that again. Assume the conjecture that the set of points equidistant from A and B is the perpendicular bisector of AB true. Okay, so let's think of a point that's in between, equidistance, that means the same distance. So this point over here, well, if we take a measure that's this length and a measure that's that length, it kind of looks like if they're the same length, then it actually does lie on the perpendicular bisector. But let's talk about what we're being asked here. Is point E closer to point A? It is definitely closer to point A. How do I know? Well, in geometry languages, it's kind of hard to know the answer to that question. But I do know the slope to get to E to A is much steeper than the slope to get from E to B, which means that it is quicker to get from E to A than E to B. So it is closer to A than it is closer to E. In order to get E to be the same distance, I would have to shift E over to right about that line, actually. So this is making me think that our conjecture is true, that if we want to have a point that is the same distance from A and B, then it would have to lie on the perpendicular bisector. Because here it looks like they would have the same slopes because it would be over and up the same distance. All right, it just says explain how you know. There are probably multiple ways to explain this, so if you want to think about it or come up with your own solution, I recommend you pausing the video and doing that now. Problem 3. Starting with two marked points, A and B, precisely describe the straight edge and compass moves required to construct triangles ABC in this diagram. All right, I told you these circles were going to come up a lot in the last lesson. So let's get started. We start with points A and B. I marked A, I marked B. I'm just going to draw a circle. My circle, I'm going to call him circle B, and he is going to be this circle right here, who has the radius AB. I know that with the radius AB, that this line right here and this line right here have to be congruent because they're both radiuses of the same circle. Now let me draw a second circle. This one is going to have center A. He is also going to have the same radius. But I'm just going to draw my circle. Boom, 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 boom. Now, I know that circle A has this radius, and also this radius has to be the same. I then say, let me mark the intersection right here. And let me connect all 3 points. Well, AB is equal to AB, and AB is also equal to CB, because it's the same radius of circle B, which is also equal to AC, because it's the same radius of AC. So if all 3 of these segments are equal, then it's an equilateral triangle. And we created this diagram. We're done. Next question. Problem 4. The diagram was created starting with points C and D using only a straight edge and a compass. Using only a straight edge and a compass to construct the rest. All steps of the construction are visible. Select all the steps needed to produce this diagram. Well, we started with points C and D, and I am already an expert over here, and I know we've been doing the same thing over and over again, and I know that I start with this circle over here. Then, using the same radius, I draw that circle over there. Finally, I take my points of intersection, and I connect them. So, did we construct a circle centered at A? A is over there. No. Did we construct a circle centered at C? Yes. Did we construct a circle centered at D? Also yes. Did we label the intersections of the points A and B? We have an A down here and our B is hidden, but yes. Did we draw a line through points C and D? Well, let's double check. No, we did not. We used that as a radius. I drew a line, but in this construction, they did not. and it is not a necessary step. And finally, let's go down to F. Did we draw the line through points A and B? That was our last step, and yes, we did. All right, we are done with this question. That was easy. You get used to this construction, and the questions all start becoming pretty similar because it's the same construction over and over again. Problem 5. The diagram was constructed with a straight edge and a compass tools. This diagram right here. A is the center of one circle, and C is the center of the other. Select all true statements. Well, what do we know? Let's situate ourselves. We have A is the center of this circle, and AB is the radius. And that seems to be the only fact that I currently know right now. We know about that first circle. We know C is the center of the circle, and CD is the radius, because sometimes it's easier to see when you highlight. And that tells me that it is also congruent to CB, or the same length. Okay, let's get started on our answer choices. I always situate myself with a diagram first to know kind of what's equal before I go to my answer choices, because that helps me see when I start considering my answer choices. Is AB equal to BC? AB, is that equal to BC? Nope, or we don't know. Maybe it's off of scale, but they're not the same radius, so we don't know if they're equal or not. Is AB equal to BD? We also do not know the answer to that question. Is AD equal to 2 times AC? Well, let's think about that. We have AD, which is here. That's a segment that I did not consider in my original diagram. And then we have CD, which is here. Well, that's a radius of the small circle, or circle C. And this dotted line is also a radius. So from here to here does look like it's double the length from here to here. So yep. Is BC equal to CD? BC, is that equal to CD? Oh, they're both radiuses, yep. Is BD equal to CD? BD equal to CD. This guy's not a radius, so we can't make any conclusions about him right now. Cross him out. All right. If you like this video, please like and subscribe. And if you have any questions, please put them in the comments. I'm looking forward to seeing you in the next one.